We are grateful to present our recent work, Depth-Guided Neural 3D Scene Reconstruction, dubbed DG-Recon. In this work, we identify two common pitfalls of the existing neural reconstruction methods. The first issue is the depth ambiguity in the feature back projection process. Taking this simple scene as an example, it consists of a table, a chair, and a wall. Most methods would simply backproject 2D image features along the entire array because the depth is unknown. This could introduce many erroneous 3D features like here on the table or here on the wall. An alternative would be to guide the backprojection using the depth prior information that comes from an efficient molecular depth estimation network. In this paper, we propose to consider only those 3D voxels within a margin from the approximate depth prior. Another issue with the current neural reconstruction methods arises from the multi-view feature fusion. As we can see from this example, visual appearance is much more consistent for 3D points on surface than 3D points off surface. However, most methods apply a simple average to fuse features from multiple views. Critical information about cross-view consensus is lost in this process. In this work, we propose two alternative fusion mechanisms, one non-learnable and one learnable. Both are efficient for online reconstruction and meet the real-time requirements. These slides summarize the commonly used mechanisms for multi-view feature fusion. As we mentioned before, most methods simply take an average over those features. Inspired by the multi-view stereo methods, we propose to compute the variance instead of the average. The variance-based fusion can better preserve the cross-view consensus information while being as efficient as the simple average. A few works introduce transformers for multi-view feature fusion. However, the self-attention module there scales quadratically to the number of views. We instead propose a cross-attention-based fusion as a learnable alternative, where a recursively updated 3D feature is used as the query to the multi-headed cross-attention module. This module scales linearly with the number of views, and thus is more efficient than the self-attention module. Putting everything together, here is an overview of DG-Recon. Given a stream of monocular images with their corresponding poses, our methods first extracts 2D features and estimates monocular depths. The 2D features are back-projected to 3D spaces using the pose and depth priors. Multi-view 3D features are then fused together before fed to the sparse convolution networks for incremental TSDF updates. We experiment our methods using the scanner dataset and compare against the Recon baseline. We train our methods using the scannet training set and evaluate following the standard pipeline set up by Transformer Fusion. Our methods outperform all the other online methods and reduce reconstruction results even close to the state-of-art offline methods. As a sanity check, we also show that both of our methods significantly improve over the non-learnable TSDF fusion using the same depth prior. We also conduct ablation studies to evaluate our major contributions using the ScanNet validation sets. This table here shows that the depth guidance helps improve the reconstruction result for both the average and the cross-attention fusion. By adding the depth and the view-related geometry feature, our methods outperform the baseline by more than 8%. This table here shows that both the variance and the cross-attention fusion significantly improves the reconstruction results without sacrificing much the efficiency. Last but not least, we show a live reconstruction demo with our methods. Following the same setup as Recon, our method makes incremental updates every 9 keyframes. We can see the office room is gradually reconstructed as we scan the room, with more views revisiting the same place. For example, this dustbin in the corner. The geometry gets refined with more details. Thank you for your attention. If you have any questions, please feel free to visit us at our poster sessions on Friday, 6th of October, 10:30 to 12:30.